Alright, welcome to another AQA AS chemistry video. Today I'm going to be doing a video on enthalpy changes. I was going to do a video and there'll be another video that has exam style questions based off of the previous topic, or previous subtopic, which was about bonding. I'm now moving on to energetics, but I will do a video. The next video hopefully will be the video on exam questions on bonding. And I'm trying to look for an exam paper that's like kind of AS. But I'll probably just find an A-level paper anyway, but that video will come. Alright, so I'm doing a video on enthalpy changes, so I'll get straight into it. So for a given process or reaction, we can measure the enthalpy change. And I'll just give a definition of enthalpy change. An enthalpy change is a measure of the heat given out or taken in during a process. That's the actual technical definition if they ever ask it. But I usually refer to stuff as energy as well, but that's what you need to know. Enthalpy change is a measure of the heat given out, or say internal energy given out or taken in during a process, right? When objects are heated, they grow. When objects are heated, they use energy to expand. So enthalpy takes into account the energy used in the expansion. So the problem with energy is that you have to think about, because when you heat something, for example, something gains energy, it also expands, and energy is used for that expansion, and you're not considering that energy that's used up for that expansion. Enthalpy takes into account the expansion. I explain why. It's mostly to do with pressure, because it's on the constant pressure, but I'll go for it now. So enthalpy versus energy change. We use enthalpy instead of energy because we can't easily measure energy changes, and this is because objects expand when heated. To measure energy change, we would have to fix the volume of the object, which isn't always completely 100% easy to do. But enthalpy is much easier to use as it allows for expansion. Enthalpy changes are instead measured under constant pressure. The atmosphere is at a constant pressure, so we require no extra equipment. And I'll show you what the constant is for constant pressure. It's 101 kilopascals, but the constant pressure that you need to know for your exam is 100 kilopascals. Alright, let's go on to endothermic and endothermic versus exothermic reactions. An exothermic reaction is one which gives out heat energy. An exothermic reaction has a negative enthalpy change. An endothermic reaction is one which takes in heat energy or internal energy. I don't like using the word heat energy. I got this from I'd like to use the word internal or thermal energy. That's probably a better word to use. And endothermic reaction has a positive enthalpy change. So when we're talking about exothermic reactions, because it's a net, right? Think of these as a net. It's when you're talking about an exothermic reaction, right? The overall process of the reaction, once you've totted up everything, will be more negative than positive. So we describe it as having, by this, right? Delta H is it's a negative value, whereas because more energy is leaving the system or leaving the reaction than being taken in. Whereas an endothermic reaction, there will be some exothermic, but overall the net, in terms of enthalpy change, the overall enthalpy is more positive. So more energy is going into the reaction than leaving the reaction. And I'll give a couple examples here, but we say the enthalpy change is described as being overall positively, or having a positive enthalpy change or positive energy. Combustion is exothermic. So an example of an exothermic reaction is combustion. Alright, think about a flame. More energy is released out to the surroundings. If you sit around a campfire, energy from that fire is being lost and you're taking it in. So the actual combustion itself is an exothermic reaction. If it was an endothermic reaction, you'd feel colder as the flame is going, because the flame would be taking in that energy, if you think about it. Or taking in the energy from the surroundings. So no, combustion is an exothermic reaction. So combustion is an exothermic process as it gives out heat. For example, burning methane. So CH4 plus 2O2 goes from CO2 plus 2H2O. And as you see, overall, the enthalpy change is a negative value. And in your exam, if you don't represent the negative, show us that you'll lose the mark, obviously, because that changes everything. An example of an endothermic reaction is thermal decomposition. So using heat to heat another compound to break bonds, right? Decomposition, to break apart a compound. So energy is required to be put in order to break those bonds. So therefore, the compound would be absorbing internal energy or thermal energy in order to break something down, and therefore the overall reaction is described as being endothermic. So thermal decomposition is an endothermic process. For example, the thermal decomposition of calcium carbonate. So calcium carbonate will be heated to break it down into calcium oxide plus CO2. As you can see here, the enthalpy, overall enthalpy change is a positive value, 178. You can put, just to clarify, in the exam, you can get, we don't have to say plus, like in maths, you don't have to say plus 178.3. It's the same principles when it comes to it. It's just good to write the plus, but you won't lose the mark if you don't write the plus. I know it sounds obvious, but for some reason, some people ask that. But obviously, it's the same thing in maths. You have to say the minus in order to show that it's a negative value. But you don't have to write the plus, but just write it down sometimes. You can get away with it. No one really cares. Same thing as maths, right? All right, so as talked through before, I've described enthalpy change. That's a terrible handwriting. Or it could be written as just this, right? Try enthalpy changes. In maths, delta means change. And the H here, understanding conditions. Well, I'll come on to this next part here about the standard conditions, right? But we talked about two types of enthalpy change. If it's a positive enthalpy change, it's an endothermic reaction. I mean, an example of this is thermal decomposition. Any thermal decomposition reaction. And it's because more energy is taken in, but I won't get into that. And then for if the enthalpy change is negatively I was about to say negatively charged, not negatively charged. If the enthalpy change is more negative, it's an exothermic reaction, right? If you lose something, it's negative. If you lose money, you're going into debt, that's negative. That's just need to understand it that way. And that's exothermic. Exit, exo, exit, endo, it means enter. Kind of like, think about it like that. If you ever get confused between the two. I remember when I first did when I first did this in GCSE, I kind of got confused. Endo and exo. But endo, coming inside, gaining. If you gain money, positive. Something coming into your bank account, that's positive. Whereas negative, exo, something exiting, negative. Think about it like that if you ever get confused. But hopefully you're not as special as me. And I mean, when I say special, I mean disabled. Anyway, combustion of methane is an example of an exothermic reaction, or any combustion reaction, right? Combustion is an example of an exothermic reaction. All right, move on now. So, bond breaking and making. The basis of chemical reactions is a series of bond breaking and making. So this is what I mean by it's a net, because you have parts of the reaction which are endothermic and parts of the reaction which are exothermic, and it's about the overall enthalpy change that determines whether or not a reaction is exothermic and endothermic. It's not just entirely endothermic, it's not just entirely exothermic, it'll be some of both, and what you need to understand is how to just make sure that you get what's the overall, right? If I'm gaining plus 2 joules but I release minus 1 joule, overall I have a plus 1. The enthalpy change be plus 1, therefore it's an endothermic reaction. That's just basic maths, you understand the principle here. But bond enthalpies. So during reactions, some chemical bonds must be broken and made. The energy to break or make a bond is known as the bond enthalpy. Energy is needed to break a bond, so it's an endothermic process. And energy is given off when a bond is made, so it's an exothermic process. The enthalpy change for reactions is sum of the individual bond enthalpies being broken and made during the reaction. So to break a bond, you require energy. Energy is put in to break a bond, but when you form a bond, that energy is released. So it's about when you're doing this reaction, they'll give you, if you did an exam, they'll actually give you a table of, you have to like know this off by heart. They'll give you a table of the bond enthalpy of a certain bond, and you need to just know, right, if it's like a methane, right? and they say this is doing it. Oh, I can't even give an example, but let's just say CH4 and it's reacting with O2, right? You need to know that there's four in this CH4. There's 4 carbon hydrogen bonds. There's 4. So they'll say the CH bond is, right, for example, CH bond is equal to, I'm going to here with me right now. This isn't the actual value, but just say it was 484, right? And if you're adding up and then O2 is another value, you need to do 484 times by 4 because there's 4 carbon hydrogen bonds. And if the oxygen is a negative value, right, then you need to do that also. It would be plus, let's say an O bond is minus 182. I know it's not the right answer, but plus minus 182. Or you can just do minus there, but this is how you this is how your mindset of going into these. This is so messy right now, but and this is what you need to understand. It's just about doing the overall net. They'll give you the values in the exam. You just need to do to make the calculation, and I'll go through that in other videos and show examples. But this is just about showing you or understanding what's actually going on. Alright, so the overall net. During a chemical reaction, we must determine whether the reaction requires more energy to break bonds or to make bonds. And this will give an overall reaction enthalpy that is either positive or negative. Alright, endothermic versus exothermic. So since bond breaking is an endothermic and bond making is exothermic, more energy required to break bonds in a reaction will lead to an overall endothermic reaction, such as if it's, for example, if you're a massive thermal decomposition reaction, right? If you had to do a massive, the more endothermic reactions, for example, the thermal decomposition of diamonds, right? It requires a lot of energy to break, because it's such a massive kind of molecule. I guess you need to have a lot of energy to break down a crystal of diamond. Whereas when more energy released making bonds in a reaction will lead to an overall exothermic reaction. And a good example of an exothermic reaction or releasing energy is a furnace or a campfire. Like you're forming, for example, if you're using a furnace, right, you're forming CO2 and water, and when you're releasing all this energy, the combustion reaction, internal energy from the flame, that's releasing more energy to the surroundings. So that's just understand that the more endothermic it is, because there will be some exothermic character to your reaction, but the more endothermic is, obviously the overall net, which is the point here, the overall net will be more endothermic if you're talking about an endothermic reaction, or if it's an exothermic reaction, then it's more exothermic. Then the overall net will be an exothermic reaction. That's it. That's what you need to understand from this. That's Jesus, but this generally is all GCSE. You should know this by now, but this part is more A-level, right? So for more measurements, we can record them under standard conditions, and this is true for enthalpy changes. We call it standard enthalpy change, right? So standard conditions is something that's more A-level. So symbol. So enthalpy change is given the symbol H, and enthalpy changes are given the symbol delta H. So change is just in maths is usually represented by delta. And enthalpy is represented by that H there. So negative enthalpy change is one which gives out heat, i.e. it's a exothermic reaction, and a positive enthalpy change is one that takes in heat, an endothermic reaction. Standard conditions. So you hear the term standard conditions a lot in chemistry, and these conditions refer to, and standard conditions, there's lots of different reactions that have different standard conditions, but the overall standard conditions, well, there's certain ones that just always seem like, the pressure is always 1 bar or 100 kilopascals of pressure. 1 bar is actually close to 101 kilopascals, which is a constant actually. And the temperature of 298 kelvins, otherwise known as 25 degrees Celsius, but we do measure our values in chemistry in Kelvin. And it's, I think, even in science we just in general SI units we use Kelvin. And the substance's most stable state is 298 Kelvin and 1 bar pressure. So these are the standard conditions, right? when you do like things like electric potentials, there'll be other standard conditions, but just knowing at least these ones, the main ones here that you see throughout chemistry are, for at least for enthalpy changes, when you do the enthalpy change reaction with calorimetry, 100 kilopascals, 298 Kelvin, or you could say 1 bar of pressure. So for standard conditions, for liquids, it's going to be at room temperature. It's a liquid. For carbon, is graphite at room temperature and pressure. Standard enthalpy changes. So standard enthalpy change is an enthalpy change carried out under standard conditions. So there are 2 that you need to know. There are actually more that you need to know, but in terms of the definitions, actually that's a lie. Really, you need to know all of them. There's much more than just 2. But for year 1 energetics, for year 2 energetics, you need to know more. But for AS energetics, it's just the enthalpy of combustion and enthalpy of formation. But when you get to year 2, there's a lot more standard enthalpies. But when the time comes, you get into that. So the subscript theta, which you should know from math, signifies that there's standard enthalpy change. So I'll show you what it actually looks more like. It looks more like this, right? And when you see this, it means standard enthalpy. It means standard conditions. And the standard enthalpy, so this is standard enthalpy of combustion. And standard enthalpy of combustion is defined as being the enthalpy change on 1 mole of a substance in a standard state burns completely in oxygen under standard conditions of 298 Kelvin and 1 bar of pressure. This is a definition. You need to be able to say that. The enthalpy change from 1 mole of a substance in a standard state burns completely or plentifully in a plentiful supply of oxygen under standard conditions of 298 Kelvin and 1 bar of pressure, or 100 kilopascals. Another definition, the standard enthalpy change of formation is defined as the enthalpy change when 1 mole of a substance is formed in its standard state from a pure elements. This is important. Pure elements in their standard states under standard conditions of 298 Kelvin and 1 bar pressure. But when it says pure elements, it means the pure elements under standard conditions. So if you're forming a compound with using water, elements. So elements, if you form a compound using oxygen, it has to be oxygen at room temperature and pressure, which is a gas. It can't, or iodine at room temperature and pressure. So iodine at room temperature and pressure is a solid. You can't say iodine. You can't have the enthalpy of formation when iodine is a gas or liquid. That's because it's not under standard conditions. So it has to use the pure elements or elements under their standard state is another way that you can say it. I've seen this. That's the way I wrote it, at least. It's the enthalpy change when 1 mole of substance formed in its standard state from the pure elements under their standard states. You could say that as well. Pure elements in their standard states. Alright, and finally, one thing that I never really used it, I just remembered it, but if you ever really struggle between understanding bond the endothermic and exothermic, which one's bond breaking and bond forming, you could use this synonym or this kind of acronym here, bendo-mexo. And it's a good way to remember it. So bond breaking is an endothermic process. So bendo, bond breaking, that's an endothermic process, and bond making, which is the mexo part, is an exothermic process. So that's one way you can do it, but I just remember it. Alright, so bond enthalpies. So just to sum up this whole video, yes. So forming bonds it releases more energy than takes in. Remember, it's a net, so releases more energy than takes in. And this is an exothermic reaction. And then bond breaking or breaking bonds takes in more energy than releases. And this is an endothermic reaction. And that's it. Hopefully this video was helpful. I try. Please.